The goal for today is to look at what exponents mean, and then we'll do some simplifying of expressions using the order of operations. Okay, so first some exponent vocabulary. Okay, so here I have 2 raised to the third power. Okay, the number 2, that's called my base. And the number 3 is called my exponent. Okay, what it means, okay, 2 is the number that I'm multiplying, and the exponent tells me how many times I'm multiplying it. Okay, so 2 to the third power would mean 2 times 2 times 2. Okay, again, base is what I'm multiplying, and then exponent tells me, well, we're going to multiply that 3 times. 1, 2, 3. Okay, the expression on the left, 2 to the third power, that's called the exponential form. Okay, it has the word exponent in it, exponential form. The one on the right is called the expanded form. Okay, so if we write it out, we expand it, it looks like 2 times 2 times 2. All right, so when we start using variables, okay, x to the fourth, x is going to be your base, and 4 is going to be your exponent. Okay, so I'm going to have 4 things that I'm multiplying together. Okay, that's what the exponent tells me. And what am I multiplying? Well, I'm multiplying x times x times x times x. Okay, so I'm multiplying the base by itself 4 times. Okay, this is not the same as 4x. Okay, x to the 4th power. X times x times x times x. And then just some interesting exponents that you'll see. If I have a number or a variable by itself, and there's no exponent written, there really is a 1. Okay, because x is the same as x to the 1st power. Right? I'm multiplying it. Well, really, I just have it 1 time. Right? I'm not multiplying by itself at all. Okay, so if you ever see a variable by itself or a number by itself, and they ask you for an exponent, there's really a 1 there. There is not a 0 there. Okay, so in the second example, 5 to the 0 power. Whenever you have something to the 0 power, okay, you can go ahead and put that in your calculator. So 5, and then on the left of the calculator, it's about the 1, 2, 3, 4, 5th button down. There's a caret button. So that 5 caret 0. Okay, it looks like this on your calculator. 5 caret 0. Okay, and then hit enter. You would see that any number when we go to the 0 power, that value is going to end up being 1. Okay, so just 2 interesting things. If you have a number or variable by itself, you can put in 1 as the exponent. But if you ever have a 0 as your exponent, okay, that can be simplified. Okay, so anything to the 0 power will be 1. All right, so let's look at some expanded forms for these couple of problems. Okay, then we'll go the reverse way. We'll look at some exponential form, but really I want to spend a lot of time on order of operations. Okay, so write the expanded form. 4 to the 5th power. It means I'm going to have the base multiplied by itself 5 times. 1, 2, 3, 4, 5. Okay, so I'm going to keep writing that base, the bigger number, and the exponent will tell me how many times I have to multiply it. So 4 times 4 times 4 times 4 times 4. Okay, it is not 20. Okay, put that in your calculator. If you want a value, okay, now I'm not asking for a value, but that would be 1024. Okay, negative 2 to the 3rd power. Okay, the 3 tells me how many times I'm going to multiply the base. I'm going to do negative 2 times negative 2 times negative 2. Okay, and the last one with a variable. Okay, my exponent is 4, so I'm going to have 4 of them. I'm going to have y times itself 4 times. It's not the same as 4y. Okay, y to the 4th again is not the same as 4y. And then let's do 3 problems the opposite way. So here's the expanded form. We'll write the exponential form. We'll write it with an exponent. Okay, so here I have 5 as my base. I have 5 times 5 times 5. I'm multiplying that number by itself 3 times. Negative 3 times negative 3. Okay, so I have negative 3 multiplied by itself 2 times. And then x times itself, let me count, 1, 2, 3, 4, 5, 6 times. So I have x multiplied by itself 6 times. Okay, and then just here with the negative 3, okay, that negative 3 times itself, okay, I put that in parentheses, okay, because if you ever put that in the calculator, it's very important when you have negative values to understand where to put the parentheses. All right, let's spend some time on the order of operations. Okay, so PEMDAS. Okay, this is the order if you have a long problem. Okay. For example, this first one we'll do. This is the order that you have to follow. Okay, so P stands for parentheses. Okay, now for parentheses, you only simplify the parentheses if there is something to simplify inside. Like this first one. Inside those parentheses, there is a 3. Okay, you can't simplify a 3 at all. Okay, so parentheses does not apply to that problem. Okay, so when you see parentheses, it's really inside of the parentheses if you can do it. Exponents. Okay, that's the topic for today. Okay, so after you do parentheses, second thing you'll simplify is exponents. Okay, now multiplication and division. These are written next to each other. Addition and subtraction, they're written next to each other. Okay, so I stopped writing down for multiplication and division because if you have both of these, if you have both multiplication and division, you do the one that comes on the left first. Do the one to the left first. Okay, so sometimes it may be switched. It may be division and then multiplication. Okay, it depends on, in the problem, which one comes on the left. Okay, same for addition and subtraction. If you have addition and subtraction, do the part on the left first. Okay, so let's look at some examples. I'm going to write PEMDAS on the side. Multiplication and division will be together, though, and addition and subtraction will be together. So for the parentheses, again, I look at the parentheses, I look inside. Is there anything to simplify inside the parentheses? No, there's a 3 in there. I can't simplify a 3 at all. So parentheses does not apply to this problem. Okay, these parentheses really are going to mean multiplication later. There's nothing inside the parentheses. Okay, so I'm going to move on to the exponent. Okay, I can do an exponent, so I'm going to do this part first. So let me write down 25 divided by 5 again. But I'm going to do 3 squared. Okay, it means 3 times 3. 3 times 3 is 9. Okay, I'm going to look for multiplication and division. Well, I have both. I have division here. And then these parentheses again means multiplication. So what am I going to do first? I'm going to do the one on the left first. Okay, so I'm going to do the division first. 25 divided by 5 is 5. Bring down the times 9. And then 5 times 9, my final answer is 45. All right, so here are 2 more that we'll do together. We're going to evaluate. And now evaluate kind of has the word value in it. Find the value of each expression. Okay, so we're going to do the order of operations, PEMDAS. Okay, so on the left, parentheses. Oh, this time there is something to simplify inside. 3 plus 2. 3 plus 2 is 5. Bring down everything else. So that time we could use parentheses. The exponents would be next. Okay, on the left, 5 squared, 5 times 5 is 25. On the right, 2 times 2 times 2. Okay, it's not 6, you're multiplying. 2 times 2 is 4, times 2 is 8. There's no multiplication and division, but there is addition now. 25 plus 8 is 33. Yeah, we'll walk through the one on the right also. Okay, so in the parentheses this time, there is a lot to simplify. In the parentheses, I have exponents and I have addition. Okay, based on PEMDAS, I'm going to do the exponents first. Okay, so 3 squared, 3 times 3 is 9. And 2 squared, 2 times 2 is 4. Okay, I still have to work in the parentheses. They're still not simplified enough. Okay, I can do 9 plus 4 to get 13. Okay. Now the parentheses are done. There are no more exponents left. There's just multiplication. 2 times 13 is 26. Okay, and we'll do 2 more before you try one on your own. Okay, so parentheses. Nothing to simplify in parentheses on the left. It's a 2. I can't simplify a 2. So I'm moving on to the exponent. Okay, so I'm going to bring down the rest of the problem, except I can do 2 squared. 2 squared is 4. Okay. Multiplication and division. Here's the trick here. I have division and I have multiplication. Do the one that comes on the left first. 36 divided by 6 is 6. 6 times 4 is 24. Okay, on the right, I can simplify the parentheses. Okay, in that parentheses, I have 1 plus 4. Okay, so I'm going to bring everything else down, except 1 plus 4 I know is 5. Bring down the squared. That's outside of the parentheses this time. Okay, so I have to wait for that. Bring down the minus 5 squared. Now I can do the exponents. Okay, so I have 5 squared here I can do, and I have 5 squared over here I can do. Bring down the 4. 5 times 5 is 25. 5 times 5 is 25. Okay, now I have multiplication. I have 4 times 25 and subtraction. I'm going to do the multiplication first, and then I can do the subtraction to get my final answer. All right, using the order of operations, see if you can simplify this expression. Hopefully you weren't fooled by these brackets. They're just another way to write parentheses. So we're doing inside of there first. Okay, so 6 minus 4 is 2. Moving on to the exponent now. 2 squared is 4. Okay, I only have multiplication and division left, so I'm going to do the one on the left. 5 times 4 is 20. Okay, do this one step at a time or else you're going to get the wrong answer. Doing the one on the left is division now. 20 divided by 2 is 10. And finally, 10 times 3 is 30. Okay, and if you have time, there is one more that you can try out. Okay, in the parentheses, 3 minus 5 is not 2, it's negative 2. So I have 5 times negative 2 minus 6 plus 2 times 2 times 2 is 8. 5 times negative 2 is negative 10. Okay, so you may have to use a calculator or you got to know your integer rules. Negative 10 minus 6 is negative 16. And negative 16 plus 8, final answer, is going to be negative 8.